I'm Ryan Jarvinen, a developer advocate on the on Red Hat's OpenShift team. You could find me online as Ryan J on GitHub, IRC, Twitter, most places. And I've been talking about OpenShift and Kubernetes for quite a while now. For folks that are new to Kubernetes, this is something that has evolved over the years. It kind of started out as a system within Google for managing large collections of containerized processes over arrays of machines. And they had a couple projects internally, one called Borg and then another called Omega, that helped kind of lead the way along this line of tooling for operations professionals and site reliability engineering type folks. And Kubernetes is their kind of third major attempt at this way of managing processes. And at this go, they've worked with the open source community, and Red Hat especially has been a major partner in this effort. And it's been a major leap forward for cluster scale computing. And we'll kind of cover some more details of what Kubernetes offers throughout the initial sections of this presentation. So on a more technical level, Kubernetes is really meant to be an enterprise-grade distributed process scheduler, acting over multiple machines at really kind of a cluster-wide scale. This platform essentially provides declarative controls, basically spec files, which are written either in your choice of JSON or YAML, which make it very easy to manage workloads in an aggregate form. You can manage collections of highly available production quality processes using really efficient tooling, and hopefully reduce the amount of code that you have to write over time when dealing with these complicated distributed solutions. One major piece of the Kubernetes soft infrastructure is called the control plane. It's a group of machines, or in Kubernetes terminology, nodes, that are responsible for hosting core platform services. This includes pieces like the Kubernetes API, which offers a control point for managing basic resource types. These resource types allow you to provision new containers and manage your workloads via this simple API. There's also a very nice collection of command line tools. I'll be showing a couple command line examples as we step through this content. Behind the Kubernetes API is a distributed data store called etcd. etcd is used to keep track of this cluster's state. Depending on the amount of tolerance you want to have for failure in your cluster, you might choose to have more or fewer etcd instances, as well as Kubernetes API instances. 3 or more generally gives you the high availability type of feature, which is generally what Kubernetes is trying to solve for, the ability to provide highly available solutions, and providing a highly available control plane and data store is a critical part of the solution there.